And so today I'm gonna like introduce a tool we developed before, which is a pneumatic robot, and I will like help you to go through the tool and to design your own project with this tool. So it's actually a quite common structure in like engineering, robotics, and human-computer interaction. So the tool, so this pneumatic structure is composed of like a lot of tetrahedron, like a truss structure. And truss structure is very common in engineering because it has like really high volume weight ratio. It's very light and it's very structurally strong because they are all like tetrahedron and triangle. And also in robotics, like people use it to build some very simple robots. The simple, I'm not saying it's like not do a lot of things, but it's like have a very simple structure. It doesn't necessarily need like 4 legs like all Boston Dynamics robots, but it can have like a very arbitrary geometry. So like the work on the bottom, this is fully like evolved from evolution algorithm. So nobody defined how the robot looked like at the beginning. It only began from like one triangle. And then the researcher set some target, like I want this robot to move forward on the sand, or I want it to turn around. And then the evolution algorithm just try to like grow some legs or arms for this robot and turn into the robot like this, and it can move on top of the sand. And this is another prototype that you can see. One part of this structure is, so there are a lot of linear actuator. Each beam is a linear actuator. If you give pneumatic power, it will elongate, otherwise it will contract. And you can see if you want to control each individual beam, then you need like a lot of tubing to connect it. So it's a quite complicated setup. And there are also other works in human-computer interaction, like Alexandra Ion. She built this, like she helped build this super large like dinosaur with all the plastic bottles, and she embedded like 2 or 3 motors to make it like locomote. It's kind of like decoration for the Disney park. And so you can see that one constraint here is like usually people only build like simple shape because you need a lot of tubing, or you build large shape but only with like 2 or 3 actuators, so the dinosaur can only like turn around and nod the head. And also like NASA published a paper like 30 years ago saying that this tetrahedron structure can be used for like exploration in the space, because like usually you need to bring very light things to the space to save the fuel, but you still needed to go like really large volume to help you to manipulate something or serve as kind of structure for the for people to climb onto it. So these are the tetrahedron used before. And so here's like our solution. It is called New Mesh. So I will just play video and talk through it. So it's also like linear actuator, but there are some add-on structure. Like one thing is there are 3 steps of clamp structure. So you can manually adjust the clamp to control the contraction ratio. So if you change the position of the clamp, the tetrahedron will not isotropically expand anymore. It will choose like a certain length for each beam. And the second thing is you can also change the channel connection. So you don't necessarily need to actuate every beam separately. You also don't need to actuate them at the same time, but you can like group some of them based on the color and actuate like a part of them at the same time. So you will play with this design tool to iteratively design like geometry and then assign the channel connection and the contraction ratio to this geometry. And you like play with how to control this one and eventually make into a local multiple shape-changing interface. Or maybe not only local motion, but you can also do something other than robots. For example, we did a workshop before, and like the designers helped to design some like robotic arm or flower or like a cylinder or like shape-changing fish, if you can tell from their abstract shape. So I want to say like this geometry, the advantage of it is like quite flexible. You don't need to like define where is the body, where is the arm, and it can do not only like the like the bending or like rotation by the motor, it can do like expansion and expansion in like either X, Y, or Z direction. So I will quickly go through some of the small design concepts here. One is this channel connections, this like contraction control. You can like switch the blocker structure to control how much percent each beam will contract. And the second thing is yeah, you've already seen this. The next thing is, so there is specific like drawing design. As you can see, like these are the channel, and different color means they are like interconnected into different groups. And you can see the channels here, only these three are connected, and these blue three are connected, and the green, the green one is also connected. So you can see the air will only go through like a subset of the channels here. It will not go through everything. So every time if you give air pressure here, only these two will get the same air pressure, but the others will not be affected. And what happens here is, so it's looking like something like this at the beginning. So only the blue part is actuated. So it's like darker blue color, others are like transparent. And what will happen is only the blue one elongate. And if you change it to like blue and the yellow, so yellow is also actuated, then the other subset of the beam will also elongate. And you can keep changing it to the green one. And just deactivate every beam, and it will isotropically contract to the original double tetrahedron. And okay, is there any question for this basic mechanism or like what this geometry is about? No question? Oh yeah.
There's a limitation to how long a single channel can be.
Ideally this can scale up in different scale, because you can see it's just like linear structure. If you have like this small linear actuator, you can make this small interface. If each linear actuator is this big, you can make like gigantic table or any furniture. And I actually like just wrote one. Oh, and this is a single tetrahedron. And so usually it's controlled by some like digital circuit, but today it just brought to syringe, and just give air pressure. And you can see, I guess you cannot see, but I will pass it around. Like only 3 of them elongated, but the other 2 didn't elongate. So you can deform the tetrahedron in a non-uniform way, and you can turn it back, and then you can activate another channel. So it turns into like a sharper like tetrahedron instead of like a fatter and shorter tetrahedron. I will just pass it around. Okay, I will move on to the instruction part. So I guess you can all get access to all these web pages. And so I think the main thing you need to look at is this tutorial. You can just follow the tutorial to see how you can use this tool to do all the editing. And right now I will just quickly go through how to do it just with the web page. Oh yeah, maybe everybody like open this web page and
it's on our website.
Do it together.
It's linked under today.
So if you go to like tutorial link today, you can just go to the tutorial and go to the bottom of the tutorial. You will see, no. At the beginning of tutorial, you will see there is a like open the tool, and there is a web page, and you can go there. Have you all opened the tool? So just walk around. Okay, so in this interface on the right hand side, you can see all the tools here. And the idea here is you need to first define the geometry of this truss structure. And second, you need to change the channel connection and change like which part to actuate. And the third is you need to control it in a time sequence. So I will explain them one by one. The first two is like download and load. This is just in case sometimes there is something accidentally happened and you need to refresh your browser, so you will lose all your design. So what you need to do is just like when you're doing editing, you need to like save it occasionally. You can do the same thing is just click download and you will get a JSON file here. And if you lost something, you want to like go back, you can just load it with the JSON file. And second part is to do the editing. You can see there is a small tab called edit shape here. You can click this or you can click like the E button here and you will have another sub menu here. And when you click this edit shape, you will turn into a mode that you can edit it. And also there's no gravity and everything is paused. There's no simulation at this moment. So in this mode, you can add more tetrahedron or you can change the geometry of this tetrahedron. One thing you can do is you can add another joint on top of the existing structure. So you click one joint and click add joint or like click A and you will have like new beam here. And then if you want to connect it with existing joints, you can click, just use left click to click like 3 joints and click the connect joints or C, and they will be connected. So if like you have 3 joints, then every pair of these 3 joints will be connected. And however, this is not like a preferred or stable status because as you can see, right now the air pressure is off, so it's like vacuum inside, and this beam is elongated, which is not true. And why this happens because there's no simulation at this moment. So what you need to do is you can just occasionally, after design several like actuators, you can switch off this edit shape and it will drop down and contract to its preferred geometry. So now it's like symmetric double tetrahedron structure. And you click add shape again and you can keep editing on top of this. The one common function you might need is add tetrahedron. So you can click like 3 points and click add tetrahedron. So you can directly add a tetrahedron instead of doing the previous process. And if you regret what you did, you can always click the Command Z to undo it. You can click Command Shift Z to redo it. And if you don't like this and you don't want to redo it, you can like do the like remove joint to remove the joint and all the neighboring edges. And if now you add like 2 joints and you don't want to be here, you can click the move joint button here and click the joint and move it to somewhere you want. And if you switch on the move body, then when you drag one joint, the whole mesh will go with you. And so this function is actually not very useful because you can just click like center model to put everything back in the middle, and you can use these 3 bars to rotate the whole geometry. Okay. So this part is about how to change the shape. And sometimes you might see some artifacts like one beam is intersecting with each other because we're trying to make this tool really like real time and can be run on every web browser. So there's something like self collision is not implemented. So because today we are not claiming this will be fabricated in real world. So there's something like this happen, but that's good. But that's okay. So you don't need to worry about that. And Okay, so this is the first part about building some shape. And you can see if you're iteratively adding more tetrahedron, this can go wild like the dinosaur you saw before, or you do like tower or table. You can all do it do it by this, like just playing Lego blocks. And the second part is you can actuate it like separately, not like globally. So if you click the channel color, switch on the channel color here, you will see they're all blue. That means they're all interconnected. And if you see like there are several bar here, that means there are like 5 air channel possible, but all of them are off right now. So if you switch on the blue one, then all the blue beam will elongate. That means like there's positive air pressure inside. And if you switch it off, it will go back. And now if I only want to actuate part of it, you can select like 3 or like 4 of them. And then you can see they're like different color here. That means right now they're assigned with a blue channel. And if you click yellow, they will be assigned with a yellow channel. And if you switch on yellow, only like 4 of them will elongate. And blue, that's the others. And you switch on both, the whole shape can expand. So you can see, although we are having limited number of actuators, not like every beam has 1 actuator, but if you only have 2 channels, you can have a combination of 4 actuation status. And if you have 3, you can have like 8. So what does it means like you can like use just a limited number of actuator, but have a lot of different motions. And so that's the part about controlling the channel. And in reality, if you do something like this, then you can imagine this joint, the channel inside is a little bit complex. It will have like 1 branch, like 3 channels connecting these 3, and the other channel connecting these 2. And that will be like automatically generated by our another tool, but that will not be included in the design session today. And after you controlling the channel, we can do is we can control the contraction ratio. So right now, every beam is fully contracted or elongated. But as I mentioned, you can like change the blocker position to change it. So you can see if you select 1 beam and control this contraction ratio slider, you can like add the blocker structure here. And right now it's contracted status, but it does not contract because it's blocked by the structure. And you can do something similar to other parts. Okay, and other things here is if you don't want gravity for application, like you're like designing a fish in the water, you don't want too much gravity, you can switch this off so it will be floating. And you can pause it by like click the simulate, and you can for example, if you want this structure to be fixed on the ground or fixed somewhere, you can click 2 points or multiple points and click the fixed joints here. There's a lock icon here. And then they will turn blue. And right now, if you actuate it, these 2 points will not move. So when you're building some shape that's really tall and not stable, you can use this to fix it on the ground. And there are other functions like active or passive beam. You can ignore them for now, or it's basically you click passive, they will just turn into passive beam only, conveying air, but it will not elongate at all. So, and the last function here is the number of actions. So right now you can only control how it looks like at this moment. But as you saw before, it can be like animation, it's sequential motion. So what you can do here is you can drag this bar, and so you can have like multiple time steps. It's kind of like you editing an animation. You can like put multiple time frame there and define how it looks like in each time frame, and it will interpolate between. So here, if you click this one, and click this one, and click this one, so you can see there is a red frame here. That means what time step it is right now, and it will keep looping from left to right, and it will behave just like how it looks like on the left part panel. Yeah, one thing just to remember is always like do the download and load if you have some small progress. Otherwise, you might just lose everything. And Okay, that's the tutorial part for the tool. And if you have any question, you can go to tutorial link and see how it is used. And here are some examples. So these are something like designed by the previous participants. And you just saw them in the video. But another thing is this structure is actually possible to be optimized for more complex motion, just like the evolution algorithm in the previous related work I just showed. So shape is very complex and you want to do some motion that's not so intuitive. It's very hard, like you need to try, oh, I want these like 3 beams to be grouped together and I want how much contraction ratio assigned to which beam. And it's a super large like search space for human to do it. So instead, there's some shape that we can optimize. Like this one is your goal is you want a dog or any kind of animal to do the working, to do like a local mode forward. And there is an algorithm to automatically tell you, okay, the channel should be look like this, and the contraction ratio of each beam should be like this. So, and there are other optimized example, like this dog will just like fall down on the ground, but the dog can like stand up by itself. And yeah, so in this case, the target is I wanted like to rotate 90 degrees and rotate back 90 degrees. And like some fish and lobster and other robots. Turtle. Okay, so as you can see, a lot of optimized geometry so far are robots. But actually, you can go beyond robots. Like you can have a shape-changing table or shape-changing like bridge, even it's not buildable. So you can claim if you have like a really large beam, you can build an architecture. So you can create anything you want. And now it's the practice time. And so what time is now? Okay, so you have like 8 minutes to try to create a column structure in this tool and give it like 3, maybe too much, like just 2 different motions. 2 different motion means like you have like 2 time frame and they can do different motions. So a column, yeah, you can start to do it right now and we will go around, and if you have any questions, feel free to ask me or Stephanie or Lining. And I will just quickly show how to do it here. So by saying a column, it's not like really a like symmetric cylindrical column, but it's like composed of multiple tetrahedron. What you can do is you can like click 3 points and click add tetrahedron to add 1, and you just iteratively doing this until you turn this into a like into a column structure. Because it's not like cube, so you cannot let it go just all the way up, but there might be some twisting here. It is fine. It's just roughly looking like column is fine. And after you getting some column structure, so you can imagine it will fall down right now if I just let it simulate. So what you can do is you can click 3 drawings here and click the fix points. So it will be fixed on the ground. And if you uncheck the edit shape and you click this button to elongate, so it will be like fixed vertical column doing some kind of expansion. And you can change it to different channel to give it different motion. Like if I change these multiple of them to yellow, then they will not contract, or they will not elongate together with the blue one. So in this case, I can have like 2 motions. And if you make it longer and you give it more channel, it can like doing something like a robotic arm or a snake to reach different place and do some grabbing or manipulation. Okay, now it's your time and you have 5 minutes. Okay, now let's move on to next stage. And if you're still not finished the column, you will still have a lot more chance in the later of the class. So now you're gonna like group into 3 and do some like brainstorming for what kind of shape you can make, what kind of application you can build with this structure. So there are something we have been thinking about in addition to what we build. One thing is you can actually change the gravity of the geometry. It's like not right now, but it's possible that you inject liquid into some of the subchannel instead of always air. And in that way, you can change the center of gravity of the whole mesh. Like if these 4 beams are injected with like liquid, then the center of gravity, which is like this pink ball, will go to the right, go to the left. And if it go crazier with some like algorithm and some shape design, you can see it can turn from like banana shape to a bottle shape and to a hammer shape. And based on the application, based on meaning of the object, the center of gravity can go from like middle to the bottom, like with liquid there, or go to the top because like the hammer has a metal part on top. And so that's one direction to think about, is to do a lot of shape design. And it can, like one single mesh can turn between multiple shapes. And it might be used in like virtual reality. If you are imagining or you're seeing, you are like having some different shape. But actually with Oculus, you can only have a same handler with always the same weight. You cannot feel any difference in the weight change or the center of gravity. But if you're like grabbing some mesh and it has some gravity change and shape change, it's a more realistic handling experience. And I think you've seen like the glove designed by Oculus before. Like the glove will give you like feedback when you're grabbing something. However, it still cannot give you a gravity information because only when you're grabbing something you will have the feedback. But if it's like heavier, you cannot feel it. And the other things is like you can put it on body. You can design some on body structures, and you can design some like furniture that like a table will walk around and turn around and tilting the angle. Like you go into the party, you can like have a cup of glass on top of the table, it will just move with you. And if you want to like do some sketch, it will tilt by like 45 degrees, so it will turn into like sketch table. And there are other things you can think about is in architecture. There are bridge and like rooftop. They are all very simple structure, but if you can like let it actuate, it can turn from like flat rooftop turn into some organic rooftop shape. And the bridge, it can turn from like straight bridge to some like curved bridge to let the boat go through. And like in nature, you can like think about some octopus or some animal that can do deformation. And like the Pixar lamp is kind of like a mesh structure. And you can think about the chair and the car geometry. And so you can see like using this tool, there are a lot of limitations, but a lot of time you really need to design within the constraints. So the constraint here is like you have limited number of beams. It's very hard to like in the class to build something like this. That's not possible today. So you need to think about some shape that can be designed with like maybe 20 or 30 beams. And also the contraction ratio of the geometry is still not super huge. So maybe you can change a banana to a bottle. If you want to change a banana to something crazy like octopus, that's not possible. So if you want to do some shape change, there is a range, there's a limitation. And also like the contraction ratio change, you only have 3 stages. And all these constraints are given by the physical limitation of the system. And so the goal today is just to try to do some interesting design within all these constraints. So now yeah, similar to Leah, but trying to fill another sentence is like for people, for some person, the user who is in some situation, a trust, like you just give a name to the trust you design, or do some action given some triggers. So it's not only like one action, one trigger, but maybe like 3 action under 3 triggers, because you can like have multiple time steps. And just click this form link, and every group you can start like doing a sketch in the following 15 minutes. Just sketch some idea either in like mesh looking or just like some arbitrary sketch, and then you fill this sentence. And you so I just placed the like 3 trigger and 3 action. You can like write only 1 or 2 of them, or just fill all of them, and then upload your sketch here. And okay,